Alright, so in the previous video we saw how we can pre-train a model using SimCLR. Let's now actually use this pre-trained model and train it further on our target dataset. Yeah, as always, it's good to start with the baseline. So here I'm using a notebook that we used earlier already, where we have our PyTorch Vision Hub and load the Resonate 18 model without pre-trained weights. And then we train it on Cypher 10. So this is really a notebook that we saw earlier. So I'm just scrolling through this rather quickly here. And this notebook, for reference, achieves about 81.9% classification accuracy on Cypher 10. Now what we want is we want our SimClear pre-trained model to perform better if we train it for the same number of epochs on the same Cypher 10 dataset here. So we want the accuracy to be higher than here. Of course, it's overfitting, as we can see, but that's a separate issue. Here we want to keep it as simple as possible and just see if our pre-training helped. So here I have a fresh notebook where we are now going to load the pre-trained model that we pre-trained with SimClear in video 7.7 part 4. So as usual, we start with the package loading, and then we are going to use again the Torch Vision Hub to first load the architecture. So since we saved in the previous video the model with a safe dictionary approach, it will only save the model weights. This is recommended, by the way, for compatibility reasons, but this requires us also to load the architecture first. So, and in that way we have to replicate what we had in the previous notebook. So we had the architecture and we also had our two fully connected layers that we added onto this. So this is essentially what we had in the 7.7 part 4 video. I'm just copy and pasting it here. And then we can now load the PyTorch model, or essentially the PyTorch model weights, using the load state dict approach here, where this will load the model weights into this architecture. So we are going to use the SimClear ResNet 18 PT model weights that we just saved. So here we are using the SimClear ResNet 18 weights that we just saved in the previous video. And then what we do is we also change this now to a classification task. So before this was for the embedding learning, now we are chopping off our two fully connected layers for the embedding learning, and we are just using everything before and define a new output layer. So this output layer will be our classification layer. So we say linear 512 10. You could technically also just replace this last layer. This is really up to you. You can experiment this. That would be actually an excellent exercise. Maybe I should turn this into an exercise, see what performs better. Yeah, and then we can actually reuse our previous Lightning module that we had for classification. We just instantiate our dataset, the Cypher 10 dataset. We use the previous Lightning model, not the SimClear one, the one we had before, and then train this as a regular classifier. So we can instantiate this and then just fit the model. Again, this would take a bit because we are training for 50 epochs to make it, let's say, fair compared to the baseline, which was also trained for 50 epochs. So I'm skipping ahead again, so because it took quite some time to finish the training. So here we have the results, and we can see that the loss, the training loss looks good, the validation loss goes up by a lot, which means the model is overfitting. Addressing overfitting, we had different lectures for that. To address that here, we just kept things simple to focus on SimClear, but maybe that would also be an interesting exercise to reduce the overfitting here. What we are interested in now, though, is did the accuracy improve compared to the baseline? So what does the, let's say, test accuracy look like here? And we can see it's 83.2%, which is a slight improvement over the baseline. So we can see in the baseline we got 81 something percent, and now we have 83 something percent. So it's not really that huge, and that is because we were using that small Cypher 10 data set where for Cypher 10 we don't have that many images. In the real world scenario, we would use a very large unlabeled data set. We didn't do that here, so that it's quite easy to, let's say, finish the training. It wouldn't take days, but that would be an interesting exercise. Also, I should say, in the context of vision models, Self-supervised learning is useful, but it is not, let's say, magic. So you won't expect, I would say, 10 or 20% accuracy point improvements. It's really, I would say, more subtle than that. It's like 2-3%, or maybe sometimes, if you're really lucky, 5%. In Unit 8, in the next unit, we will see how we can use pre-training or the concept of self-supervised learning for language models, where it's actually, I would say, a bigger deal. I wouldn't say in computer vision self-supervised learning is not important, but yeah, the improvement is usually a little bit more subtle than in language modeling, which is of course then the topic of the next unit, and I hope you are excited about that. So in this video we saw how we can use our own pre-trained model that we just trained with SimCLR and how we can fine-tune it on our target dataset.